So recall, back to Unit 1, when we evaluate limits, the first thing we try is direct substitution. So limit as x approaches 3 of 2x minus 5 over x, just try plugging in the 3 first for x. So that's 2 times 3 minus 5 over 3. That's 6 minus 5, which is 1 over 3, like that. So here, let's try direct substitution. Plug in the 2. That's 2 squared, which is 4 minus 14 plus 10 over 2 minus 2. And this gets us a 0 over 0. And if you remember from Unit 1, what we could do is factor the top and the bottom, and then x minus 2 will cancel out. But there's a way to do this without derivatives, and this is called L'Hopital's rule. So suppose f of a is equal to 0 and g of a is equal to 0, and limit as x approaches a of f of x over g of x is 0 over 0, or infinity over infinity. So pretty much what happened here, right? When we tried direct substitution and we get a 0 or over 0, or if we got an infinity over infinity, L'Hopital's rule allows you to apply the following. The limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. And then from there, well, if you need to use L'Hopital's rule again, you could do the second derivative, but you could also, if you don't get a 0 over 0 or infinity over infinity, you can then plug in what the limit's approaching to get your answer. So if we go back to this top example here, right, we would have, because we got a 0 over 0, we can apply L'Hopital's rule. So we can do L'Hopital's rule. Just do an arrow here. Limit as x approaches 2, we can take the derivative of the top, which is 2x minus 7, over, well, derivative of x minus 2 is 1. And now you can just plug in 2, which is 2, which is negative 3. That's L'Hopital's rule. Here are some example problems. Evaluate each limit and use L'Hopital's rule whenever possible. So here, if you plug in the 2, you get a 2 minus 2 over 2 cubed, which is 8 times 3, 24, minus 24, plus 2 minus 2. And that gets you a 0 over 0. So we can use L'Hopital's rule. We can rewrite this as limit as x approaches 2. Take the derivative of the top, which is 1. The derivative of the bottom is 9x squared minus 12x plus 1. And now we can just plug in the 2. So 9 times 2 squared is 36 minus 12x, well 12 times 2 is 24, plus 1, and that gets us a 1 over 13. So right here, if you try plugging in the 0 over 0, it's a sine 0 over 0, which is a 0 over 0. We can't do that. But what we can do is use L'Hopital's rule. So take the derivative of the top and bottom, which is 6 times cosine of 6x. Oops, extra parentheses there on accident. All over the derivative of x, which is just 1. So that's just 6 times cosine of 0, which is just equal to 6. This one here. Limit as x approaches 0 of 1 minus cosine x over x squared. If you tried direct substitution, you'd end up getting a 0 over 0 again. And then now you can take the derivatives of the top and bottom of the fraction. Limit as x approaches 0 is of negative cosine x is positive sine x over 2x on the bottom. And here, if you try substitution, you get a sine 0 over 0, which is still 0 over 0. So we can use L'Hopital's rule again. So take the derivative of sine x, which is cosine x. take the derivative of 2x, which is 2. And now if you plug in 0, it's a cosine of 0 over 2, and that's a 1/2. So you can use L'Hopital's rule once, twice, as long as when you try direct substitution, you get a 0 over 0 or an infinity over infinity. So if you do L'Hopital, so if you try plugging in like infinity here, right? The top goes towards infinity, and the bottom also goes towards infinity. So we can use L'Hopital's rule. Take the derivative of the top and bottom. We have 4x on top, 2e to the 2x on the bottom. Now you see we can take L'Hopital's rule again because same thing, if you tried plugging in infinity to the top and for x, you get infinity over infinity. So limit as x approaches infinity of derivative of 4x is 4. The derivative of 2e to the 2x is 4e to the 2x. And now if you, well, the 4's cancel out on the top and bottom, you're left with the 1 on top. And then as x goes to infinity, right, the top remains 0, and the bottom is like an e to infinity, a very large number. 1 over a very, very large number is the same as 0, right here. So one thing to note, L'Hopital rule is not the same as the quotient rule. So you see for like questions 2, 3, 4, and 5, right, we're finding the limits of each of them, the limits of a function, which happens to be a fraction. Here, they're just asking you to calculate the derivative, not calculate any limits. So if they ask you this is just the quotient rule. This is not L'Hopital's rule. So be sure you have the difference clear between them. And if you remember, the quotient rule is low d high minus high d low over low low. Low d high minus high d low over low low. So if you have the top function is f and the bottom is g, it's low, which is the g, d high, the derivative of the top, minus high, d low over low low. And if we did this here, so the derivative right here would be the bottom, which is x, times the derivative of the top, which is 6 cosine of 6x, minus high d low, so minus sine 6x, times the derivative of the bottom, which is just 1, all over low low, x squared. So again, be careful with these because some problems will ask you to find the derivative of a fraction, and some will ask you to calculate the limit. So be sure L'Hopital's rule is only when you're doing limits, not when you're finding like just a derivative by itself.